Hey, welcome back to the course. In this section, what we'll do is we will understand about the bus interfaces of the microcontroller. So whatever I'm going to talk in this lecture and in the subsequent lecture about bus interfacing, it will be almost common to any kind of microcontrollers you use, okay? But it is specific to ARM Cortex based microcontroller. But you can apply this knowledge or these points onto any microcontroller from different vendors. So for this lecture, I will be considering two microcontroller. One is my microcontroller, that is STM32F446 RE microcontroller, and I will be considering TI's TIWA series of microcontroller, that is TM4C123GX. And don't open any document at your side, so just listen to the lecture, okay? So later you can open your own data sheet and you can explore, no problem. Great. So now I'll come to TI later. So first let's stick to STM32 based microcontroller. So what we're going to do in this lecture is I'll just write some notes about MCU bus interfaces. MCU bus interfaces. So if you look at this diagram, okay, so this is actually the block diagram of entire STM32F446XC microcontroller. So as you know, microcontroller will be having a processor. So here the processor is ARM Cortex M4, which is capable of running up to the speed of 180 megahertz. And after that, what we have is lots of peripherals such as GPIOs, timers, UART, okay, ADCs, I2C interfaces, and lots of memories such as flash, SRAM, and other peripherals such as DMA controllers, USB, etc. So the processor and the peripherals, they actually talk via the bus interfaces. And in this diagram you will see different types of buses. So one is the I-bus, okay, so that stands for instruction bus. And second one is D-bus, okay, so that stands for the data bus. And another one is S-bus, okay, that stands for system bus. Alright, so if you observe this processor part clearly, so what processor basically saying that it gives you three bus interfaces, and those are I-bus, D-bus and S-bus. So now let's understand this from our programming perspective, because we are embedded programmers and everything should make sense from the programming end, isn't it? Alright, now let's take a look into this code snippet. So let me just explain what's happening here, okay? So because this is relevant to our discussion of bus interfaces, okay? So here there are some constant data. The first constant data is a string literal. Since it's a constant data, it will be stored in the ROM. In our case, ROM, that is read-only memory, is nothing but flash memory of the microcontroller. So here is one more constant data. So it's a data of type int, and here the type qualifier const is being used. So when you build this code, these data will be part of read-only section of the final executable. And when you load this program onto the target, that is onto your microcontroller, these data will sit in the flash memory of the microcontroller. So flash memory is nothing but our program memory. Now let's take a look into this data. So this is a char array of 50 bytes, isn't it? So this is a variable data. That means its content can be changed during runtime of the program. So this data is part of data memory, and the data memory in our case is SRAM. Remember that you cannot change this value variable. during runtime of the program. Why? Because it's a constant data. It is part of flash memory. And now take a look into this code. What's happening here? So this is a data copy from flash to SRAM, isn't it? So this string literal pointed by this pointer is actually stored in the flash, and the destination buffer, which is this my data array, is part of SRAM, isn't it? So that's why this is the data copy from flash to SRAM. Okay. All right. So now what you should note here is that finally, when you compile and load this program into the microcontroller, the instructions of this program will get stored in the flash memory of the microcontroller. These constant data also will get stored in the flash memory of the microcontroller. This char buffer of 50 bytes will be part of SRAM of the microcontroller. Okay. All right. So remember these points, and now let's continue. All right. So that means we have flash memory here, and this is our flash, and a part of the flash memory is used to store instructions, and a part of the flash is also used to store constant data. So this is also called as read-only data, and the flash is also used to store the vector tables. Great. So now what this diagram is now basically saying is that, so you have a ARM Cortex-M4 processor, and it gives you I bus, D bus, and it gives you S bus. So the processor will fetch the instruction on the I bus. So that means the ARM will read the instructions from the flash memory over instruction bus. That means your microcontroller manufacturer makes sure that the flash is actually connected to the I bus. And ARM uses D bus in order to read the data which is stored in the flash. And ARM uses S bus as a system bus that I will discuss later. So now apply this concept to your program. So in this program, as we know, we are reading from flash, isn't it? And putting the data into RAM. And we know that this is a constant data is present in the flash. And when the program comes over here, what happens? It is actually reading some data from the flash and putting into SRAM memory, isn't it? So this reading of data actually takes place over D bus, and ARM always fetches instructions over I bus. Okay, so but the data is fetched over the D bus. So the instructions of this program will be fetched over I bus. The constant data of this program is fetched over the data bus. Great. So that's the purpose of I bus and D bus, to fetch your instruction as well as data parallelly. So that's why the I bus and D bus of the processor must be connected to the flash memory of the microcontroller. And here you can see that this is a flash memory of 512 KB is connected actually to processor over I bus and D bus over this AHB bus matrix. And if you look closely, the flash is actually not directly connected but through the flash controller. This is a flash controller which will help you to read and write to the flash. Great. Now to understand more about this I, D and S bus, since these are actually part of the processor, we should spend some time in a technical reference manual of the Cortex-M processor, because the details about these bus interfaces will not be mentioned by the microcontroller manufacturer because it belongs to ARM, isn't it? So you should look at those documents which are released by ARM. So one among them is Technical Reference Manual for Cortex-M4 processor. And in this document, okay, so let's go to bus interfaces. Okay, here just click on the interfaces here. here you will see a bus interfaces. That is here you will see bus interfaces. And it says that the Cortex-M processor contains 3 external advanced high performance bus, or you can also say that HB light bus interfaces, and 1 advanced peripheral bus interface. So let's not worry about this 1 advanced peripheral bus interface. Just forget that for a time being. Just concentrate on this line. Processor contains 3. That is what we just saw now. I bus, D bus, S bus. Okay, these are actually HP light bus. It's just ARM's native protocol to design a bus. Okay, so we need not to know more about the HP protocol and all. These buses are bound to some protocol, and they will call it as a bus protocol, and its name is HP Lite. And as expected, they have mentioned I code, decode, and system interface. That is system bus. Now just read this. Instruction fetches from code memory space. From this address to this address are performed over 32-bit HP Lite bus. So that means this bus is actually HP Lite bus of width 32-bit. So that's the meaning of that. And ARM uses this for instruction fetches, but there is one condition. Those instructions must be present under these 2 memory addresses. If any instruction is placed outside this memory region, then I-code cannot be able to fetch those instructions. So that's the condition. Decode memory interface. Now that means they are talking about this dbus. Data and debug accesses to core memory space in this region are performed over 32-bit HP Lite bus, that is decode bus. So that means what they are saying is the data as well as debug related stuffs are carried out over the decode bus, but those data has to be present between these 2 memory addresses. Now come to the system interface. Okay, that is system bus. And what ARM documentation says is that you can also fetch instructions, no problem, and data. And you can also do debug accesses. But all those instructions, data must be present in the range, this one, and this one. So if any instructions or data present between these memory addresses, then you cannot use I-code or decode bus to fetch instructions or fetch data. You have to use system bus.